Hey everyone. So welcome to online lecture number 5. Today we're going to talk a little bit about whether one should worry about conditioning an event or not conditioning an event. That's a kind of topic that came up quite a lot in the last lecture. And also I'm going to do a couple of examples that draw on the theorem of total probability plus also Bayes' theorem. So we're going to learn a little bit about how those two theorems can be used in practice. All right, so with that, let's go ahead and get our screen share up and start the lecture. Okay, so remember this landfill problem? We talked a little bit about it during the last lecture. And the basic idea is that you have solid waste, say from, essentially garbage that is collected from homes or commercial businesses. It's brought to a landfill and dumped there. And one of the things you worry a lot about is that toxic substances in the landfill could get mobilized during rainfall and move into the groundwater and then maybe ultimately into drinking water wells or rivers and cause environmental problems. And so what we do in practice is that we put in barriers. So we line the bottom of the landfill with a couple different types of barriers to prevent those toxics from moving from the landfill into the underlying groundwater. And this particular problem is essentially focusing in on the case where you have two different barriers. You have sort of like a plastic lining or a geomembrane, as they call it, which is sitting on top of a clay layer. So they dumped a bunch of clay in, and the idea is that you compact the clay so it becomes very impermeable. And then you put that geotextile, and now you have two separate barriers to prevent nasty stuff in the landfill from moving into the underlying groundwater during a rain event. And so the problem says, okay, that's fine and good, but we've got two events that we have to worry about. The first event is that during a really heavy rainfall, an extremely heavy rainfall, you could essentially have a failure of these barriers because either one or the other of them was not working. So you don't have the double protection anymore. You only have one of them working. And so consequently, during extremely heavy rainfall, you can still have the toxics move through. So that's event one. Leakage will occur during extremely heavy rainfall because either the clay layer was not well compacted or there were holes in the geomembrane. Event two, on the other hand, basically can occur during light rain when there's flaws in both of the barriers. And so in this case, they say leakage will occur during ordinary rainfall or a light rainfall, but only when the clay was not well compacted and the geomembrane contained holes. So those are our two events that we're going to focus on. And based on the best judgment of the site engineer, we have the following information. So there's an event W, which is the event in which the clay is well compacted. So it's going to do its job. And this occurs with 90% probability. So there's 10% of the time this clay is not well compacted. Event H is the event where the geomembrane contains holes, so it essentially is not well constructed, and this occurs with 30% probability. And then there's event E, which is the event where a rainfall is extremely heavy, and the likelihood of that is 20%. And here it's important to think about the conditioning event. So really the conditioning event that that's sort of implied by the problem is some form of rain, whether it's light rain or heavy rain. And within that conditioning event, that is rain, E is the likelihood that, or the event where we get extremely heavy rain, and the probability of that is 20%. And then they give us a couple more pieces of information. They say, obviously, the quality of the construction does not affect rainfall. And so that means we can assume that construction and rainfall, either heavy or light, are statistically independent. And then they also tell us that if the geomembrane contains holes, the probability of a well-compacted clay is reduced to 60%. And so there's a statistical dependence between the construction quality of the geomembrane and how well the clay layer is compacted. So they are not statistically independent. And we're asked to determine the probability of event one during rain of one form or another, and to repeat for event two. And here I want to spend a little bit of time because the last time, well, actually, I've presented this problem a couple times. I think the first time I presented it maybe was online, and I had that during rain clause there. And then I thought, when I gave the lecture, I better take it out because I thought maybe it was confusing. And now I realize that it really should be there. So sorry about all the sort of back and forth on that. But really, the reason it should be there is because we're conditioning this probability on some form of rain. So we're not saying heavy rain or light rain, but we're just saying some form of rain, and we're interested in the probability of event 1 given that there's going to be a rain. And then we repeat that for event 2. Okay, so event 1 is going to be leakage from the landfill by poor compaction of the clay layer and or membrane holes during a heavy rain. And again, the possibility space is going to include rain of all forms, which includes heavy and light rain. So our S really is the union of a heavy rain event and a light or moderate rain event, E complement. And so that's our possibility space, which is just the same way of saying our possibility space is some form of rain. Okay, so event 1 is going to involve heavy rain in either poor compaction of the clay layer or holes in the geotextile. So writing that out in math symbols, what we're saying is that we have the union of poor compaction and holes in the geotextile, and we intersect that union with a heavy rain. And you can also, if you wanted to get really careful, you could condition that on some form of rain, either heavy rain or light rain. But remember, this union here is just the sample space, and it's conventional to, if you're conditioning on the sample space, to just simply write the probability statement without a conditional. And so we were asked to determine the probability of event 1, and so we would take the probability of that probability or that event, which is W complement union H intersect E. And the first thing we notice is that this union is going to be statistically independent of E, the heavy rain event, because we were told the construction is not statistically dependent on rain and vice versa. And so that means that we can immediately bring this probability through and express it as the probability of this union times the probability of a heavy rain. And so that's what I've done. This is the probability of the union expressed using the addition rule, and this is the probability of a heavy rain. Notice that the occurrence of a poorly compacted clay layer is not mutually exclusive with the occurrence of holes in the geotextile. So I have to use the full form of the addition rule, including the cross product term here. So I take this quantity on the right-hand side, and we just sort of move it again here. So I haven't done anything except to move the statement down. And now I'm going to kind of do a little bit of math. So what do I do next? I take the probability of the intersection of W complement and H, and I express it with the product rule as the probability of W complement conditioned on H times the probability of H. And then I recognize that I can express the probability of W complement conditioned on H as 1 minus the probability of W conditioned on H. And that's nice because I actually know what that is, right? It's 60%. They told me that the probability that the clay is well compacted if the geotextile has holes was 60%. And so I actually know what that probability number is going to be. I can also see that if I carry the probability of H through this, the parentheses here, I would end up with a probability of H here, which would subtract the probability of H here. So those would cancel. And so I can essentially drop that term and the 1. And so what I'm left with is this expression here. And the only other thing I've done is I've taken that probability of W complement and I've expressed it as 1 minus the probability of W. And so at this point, I've got everything that I need to do the calculation. I know the probability of a well-compacted clay layer is 90%. I know that the probability of a well-compacted clay layer when there are holes in the geotextile drops to 60%. And I know that the probability of holes is 30%, and I know that the probability of a rain event is 20%. And so I multiply all those through, and I find that the answer to this question, that is, what is the probability of event 1, is going to be 5.6%, or a little less than 6%. Okay, let's think about event 2. Just add a little water there. Okay, so again, event 2 is the case where we have leakage during light rain, and that has to occur, or that will only occur if there is both a poorly compacted clay layer and also there are holes in the geotextile. Again, we have the same sample space, that is the union of heavy rain and light rain, but we're interested in the intersection, essentially, of a poorly compacted clay layer, holes in the geotextile, and then light rain, which is going to be E complement, conditioned on some form of rain, either heavy rain or light rain. And again, because this condition statement here is just the sample space, this expression simplifier, this event simplifies to W complement H times, or intersect E complement. Okay, so we want the probability of event 2, so we take the probability of this event. And again, we recall that the probability of construction and rainfall, be it light rainfall or heavy rainfall, are statistically independent. And so that means that we can express the probability of this intersection as the product of the probability of the construction times the probability of the light rain. And we can furthermore express this probability of the intersection of W complement H as the probability of W complement condition on H times the probability of H times the probability of a heavy rainfall. Actually, that should be light rainfall. Sorry about that. I'm going to stop the video for a second and just make sure I haven't made an error.